Prime numbers matter because they are the pieces from which all whole numbers are built, and because many powerful ideas in mathematics only work cleanly when primes are involved. A prime number is a whole number greater than 1 that cannot be factored into smaller whole numbers. What makes that simple definition important is a fact called the fundamental theorem of arithmetic. Every whole number greater than 1 can be written as a product of prime numbers, and that factorization is unique. For example, 360 equals 2 cubed times 3 squared times 5, and there is no other prime recipe for 360. This means primes play the role of atoms in arithmetic. If you understand the primes inside a number, you understand that number. This uniqueness has consequences. Questions about divisibility, greatest common divisors, least common multiples, or how many divisors a number has all reduce to looking at prime powers. Hard problems about integers become manageable once they are broken into prime-sized pieces. Primes also let mathematicians solve problems one prime at a time. In modular arithmetic, working modulo a composite number secretly splits into working modulo its prime factors, then recombining the answers. This idea powers tools like the Chinese remainder theorem and appears throughout number theory. Something even more special happens with primes. Arithmetic modulo a prime creates a field, meaning every non-zero number has a multiplicative inverse. This is not true for composite moduli. Fields are the cleanest environments for algebra, which is why primes dominate algebra, coding theory, and much of higher mathematics. Primes are also mysterious. They are easy to define, but hard to predict. We know roughly how often they appear, thanks to the prime number theorem, but their fine structure is tied to deep unsolved problems, like the Riemann hypothesis. Finally, primes matter in everyday life. Modern cryptography relies on the fact that multiplying large primes is easy, but factoring their product is extremely hard. Internet security depends on that imbalance. So primes are important because they organize the integers, simplify hard problems, create ideal algebraic systems, connect to deep mathematics, and quietly secure the digital world.